Good afternoon to all. Welcome back to my channel. Hi, this is Manoranjan Sahu. Today I am going to solve the Introduction to Machine Learning of NPTEL SWAYAM Week 4 Assignment 4 answers which last date is 19 February 2025. Okay. Now let's start to answering this question. You can see here guys. This is week 4 assignments 4 and you can find there are near about 8 questions. Okay. And we will try to solve these 8 questions one by one. So let's start the first question here. You can see the precipitation learning algorithm can always converge to a solution if the dataset is linearly separable. Four options are given, that is true, false, depends on the learning rate and depends on the initial weightage. It is especially a true statement. That is one option A. We can provide also the answer of these questions. You can see here. The precipitation learning algorithm is guaranteed to convert a solution if and only if the dataset is linearly separable. This is due to the precedent convergence theorem, which states that if the dataset is separable, the algorithm will find a decision boundary in a finite number of states. Okay, in a finite number of states. So this statement is a true statement. Moving to the question number 2, that is consider one-dimensional dataset. Okay, x and y. This is -1, 1, 0, and -1, 2, and 1. Note x is a features and y is the output. Then state true or false, the dataset become linearly separable after using the basic expansions with the following basis functions. Phi x equal to 1 by x square. It is a true statement. Okay. You can discuss a little bit here. Using a basis functions, introduce a quadratic terms which allows a previously non-linearly separable dataset, that is one-dimensional dataset, to become a linear separable in a higher dimensional feature space. This technique is commonly used in polynomial feature transformation and Conlon method in SVM, support vector machines. That's why it is a true statement. Moving to the question number 3. For a binary classification problems with loss functions, which of the following statement is correct? Four options are given. This out of these 4 questions, we can choose the most appropriate option. The loss is 0 when the prediction is correct and the margin is at least 1. Okay, we can here little bit discussion. The loss is 0 when the correctly classified points lies at least a margin of 1. Okay, from decisions boundary, if the margin is less than 1, there is a loss. If it is less than 1, there is a loss. So the loss is 0 when the prediction is correct and the margin is at least 1. Moving to the question number 4. For a data set with n points in n dimensions, what is the maximum number of a support vector possible in a hard margin of SPM? What is the maximum number? Maximum number will be the n. Okay, if there is a n points and n dimension, the maximum number is m. We can discuss here. In the worst case scenario, all the n data points can be support vectors, especially when they all lies on a margin boundary. In practice, only a soft data set of points typically become support vectors. So, out of these 4 options, n may be the appropriate answer. Moving to the question number 5. Moving to the question number 5. In a context of a soft margins, SVM, what happens? The number of support vectors as a parametric increases. Okay. If the parametric increases, then what will be? It will be the generally decreases. It will be generally decreases. How? See, generally decreases. The C parameter in SVM controls the trade-off between the maximizing and margins and minimizing the misclassifications. A higher C penalizes misclassification more, leading to fewer support vector as a model prioritizes correct classification over a large margin. Conversely, a lower C allows more misclassified points, increasing number of support vectors. Okay. 5 option B. Moving to the question number 6. Consider the following data set. Okay, X and Y. X is the features and Y is the output. Which of the these is not the support vector using a support vector classifier with polynomials? Big equal to 3, C equal to 1, and gamma equal to 0.1. We recommending using sklearn to solve these questions. Okay, so it may be 6 option B. You can see here 6 option B 1. Okay, explanation is here. This requires an implementation by sklearn to determine the exact support vector. However, based on the dataset properties, SVM theories, not all the points become support vectors. Only those to close decision boundaries. Here, Point 1 is like to be well separated point. While well separated point, meaning it does not contribute to the support vector set. Moving to the question number 7. Moving to the question number 7. Train a linear precedence classifier on the modified dataset we recommended using Scalon. Use the first two features for your models and report the blessed classification accuracy. One, real one, and two penalty items. Okay, four options are given. You can see seven. Seven option A. Option A 0.91 and 0.64. This question requires a precedence classifier using Scalon, but its experimental the base classification accuracy is 0.91 and 0.64. Okay, so this one 7 option A. We are choosing 7 option A. Okay, 7 option A. 7 option A. The best classification accuracy obtained for L1 equal to 0.91 and L2 equal to 0.62. L1 regularizations encourages sparsity while L2 prevents large weight values. Moving to the last question, train SPM classifier on the modifier in its dataset. We recommended using Scalon. Use only the first three features. We encourage you to explore the impact of varying different hyperparameter of the models, specifically different kernels and associated with the hyperparameters. As the parameter assigned the trained models with the following set hyperparameters RBF kernels, gamma is equal to 0.5. One VS race classifier, no features normalizations, type C equal to 0.01. For the above sets hyperparameters, report the best classification accuracy. Best classification accuracy, it is after calculating 0.99, you can see 0.99. Highest accuracy 0.9 for C equal to 10. The RBF kernel capture non-linearity well and increasing C priority correction classification over a large margin. Improving accuracy. The result is based on empirical experiment using Scalon. Okay. So this was the last question. 8 options is the answers. Now we attempted all the questions, guys, here. Okay. Now I'm going to submit the answer. Okay. Now assignment, your answer are successfully submitted. Okay. We attempted all the question. Question 1, 2, question number 1 A, question number 2 A, question number 3 B, question number 4 D, question number 5 B, question number 6 B also B, question number 7 option A, question number 8 option C. Okay, and now we will produce week 5 assignment 5 answers. So you have to prepare yourself for your exam if you are going to face the exam very well. Okay, till then thank you, and if you like this channel you can subscribe and you can share this channel with your friends and colleagues.